Well, welcome to our second talk. Our presenter today is Lennart Regebro, and he is going to be telling us about prehistoric patterns in Python. Please make him welcome.
Thank you. Yes, my name is Lennart, unpronounceable. I've been working with Python full-time since 2001, which is a fair bit of time, and I've also written a book. This is open source. It exists on GitHub. You can fix bugs and add stuff to it if you want to. I'm born in Sweden, but I live in Poland with my wife, daughter, cats, and fruit trees. But I work for a company in Boston called Shoebox. We make a web app that helps you with a lot of the legal documentation and the legal paperwork and all this kind of stuff for corporations. You get the elevator pitch up there. If you don't understand what it says, don't worry, your boss will understand it. Tell them about us. We are apparently awesome. Everybody says so. But enough about me. This is old code patterns, because Python has gained more features over the years. And some things we used to do make no more sense. And there's lots of old code out there, so I will try to explain why it looks like it does. And old doesn't mean unmaintained. If you wrote a library or framework that needed to support Python 2.4, you had to write things in a certain way. And that code still works. So therefore, it doesn't get changed. The tests passes and everything. So you may encounter some of these in maintained code as well. There's also old tutorials and old books floating around on the internet that people still use. So they end up using and learning these old patterns. So if you're using these patterns, don't feel bad. I won't judge you. Let's start with dictionaries. When it comes to dictionaries, the first thing is stop using hash-key. In has been since 2.2, it's 15 years. And if you think I'm silly for mentioning this, because I thought I would be, so to speak, let me present to you a GitHub search. So when you search for hash-key on GitHub, it tends to show up every few minutes or so in commits. Not that people actually type hash-key and push that, but that they are maintaining code and adding and changing files that is consistently using hash-key on dictionaries. So it's pretty common, actually. I even found this, but don't worry, the actual commit replaces hash-key with in. It's just a commit message that got backwards. Easy mistake to make, especially if you're a dog. I'm impressed it knows Git. Another thing you don't need to do is to use the keys method when you list over dictionaries. I don't think this really is an old pattern, unless maybe you needed to do it in Python 1.5 or something, I don't know. But I don't think you ever needed to do it in Python 2 at least. This is not as common as hash keys, but there's a fair amount of matches on GitHub for this too. Just skip the keys call. And this code that I showed here, that's from the latest version of Django. So you go like, ooh, but it's from a test, so it's okay. This is also fairly common, and in general, if you end up using the keys method, you're probably not doing it exactly right, because this creates a list of keys, which you sometimes need. But in Python 3, it doesn't create a list, it creates an iterator. So what you should do is this. This will always make a list. And if you want to use an iterator, you should do this, but I don't know why you would, because an iterator is for iterating over, and you can iterate over a dictionary without using iter. So, all right, enough about dictionaries. Next up, sets. Sets are useful. They have, they're very fast, and the values have to be unique. So that has its uses, but it only appeared in Python 2.3 sets. So what did you do before? What do we have otherwise that is fast, has unique values, and fast lookups? Yes, dictionary case, exactly. So I lied, this pattern is also about dictionaries. This code here makes a list unique by putting it into a dictionary with values of none for all of the keys. And then it gets a list of keys back. So now we have made the list unique. Very useful, but today, of course, you would just make a set. And another usage of dictionaries like this that are full of just non-values is if you want to do very fast lookups, if you have one list of values that you want to check, is this value in some sort of list of values? Using dictionaries there is between 35 and 60 times faster compared to list, and this is for a set of 200 random integers. So it's not that big. So dictionaries are way faster than lists. And it used to be a pattern that if you needed to do this a lot, you used a dictionary. But now, of course, you would use a set. So if you're making a lookup to see if value X is in a list, in general, you might consider to use a set instead of a list. Because sets are still faster than dicts, don't worry. Okay, enough now with dictionaries for reals. This is uploads to GitHub from 2016. I don't know if this also has happened in 2017, but these are the most relevant when you look for certain bits of code, when you look for keys. And it's uploads of the Python cookbook. And I checked, it's not the current edition 3. I think it's the edition 1, maybe 2. But the code is most definitely from 2002. So, but people still use these tutorials, apparently, to learn Python. So the code looks like this, and it takes a list of keys from OS environment, sorts that, and prints it out. And why would you make a list and then sort it? Well, in 2002, this was the only way you could sort anything. The sorted built-in came in 2.4, so now we just do this. Less lines means less bugs. And this is also more robust because sorted can use any sort of iterable, not just lists. So it can take like a dictionary in this case, or sets, tuples, generators, whatever. Even better would be if we could do this as a list comprehension, of course, but we can't because of the print statement. Or can we? We can. It's a function in Python 3. If you're stuck on Python 2, well, I'm just kidding. You can do this in Python 2 as well. Yeah. So sorted is preferred over using sort on a list, unless you're absolutely sure it's a list. It's slightly faster because sorted has to create a new list, while the list sort method sorts in place. But the difference is about 1 or 2%. This sorting pattern, however, is all about speed, and you're unlikely to therefore encounter it. But if you do, please fix it, because your code is going to get much faster. This is a code this code is from a book, but I have anonymized it, changed it around, and changed the variables, so you won't be able to find it, because it's definitely not from 2002, so it's a bit embarrassing. It's sorting things with a with a comparison function. So it has a lambda that takes 2 arguments and compares them with the built-in CMP function, which returns 1, 0, minus 1 to tell you which is larger. And that's why it looks a little strange there, and the lambda starts with a minus. This is to make a reverse sort. But a comparison function, it compares pairs, and the longer the list is, the more pairs there are. So long list get very many calls per item. For 40,000, it's about 8.5 calls per item. And it also has 2 get items. So you get 680,000 calls to get item, basically, when you use a comparison function. So in Python 2.4, a key function was introduced to both sorted and sort. And the function now got much simpler here. The key function is just half of the comparison function, basically, and you have a reverse flag. And statistics is also very different. You get exactly one call per item always. So this means that with a comparison function on a list of 40,000 items, we get around 17 times as many calls to get item. So sorting 40,000 items takes about 5 times as long with a compare function versus the key function. So please switch to key. CMP is generally deprecated. The built-in was actually removed from Python 3.0, but it was added back in because it does have some use. That goes for dunder CMP as well. It's deprecated now and ignored in Python 2. And instead we have rich comparison functions, they're called. So less than equal, and so on. There's plenty of reasons to use this instead of dunder CMP, because, for example, things may be equal to each other, but not actually sortable. And then you need to do different kind of implementations here. But CMP has a big benefit. It was only one method, the dunder CMP. This is 6. So people didn't use it very much. So therefore, they got func tools to come to the rescue. There's a total ordering decorator. And now you need to implement 2 equals or not equals and one of the other 4. And this decorator will supply the other 4 methods. This pattern is funny. This is an old one that I've used a lot, especially in ZPT templates and things like this. So HTML templates where you needed to have an expression. You couldn't write anything proper. It looks like a logic expression, but it isn't. It's a sneaky conditional. What it means to say is that if use blank is true, then result should be blank value, else result should be default. But this has a big problem. If blank value is an argument and you pass in something that evaluates to false, result will actually not become blank value even if use blank is true. It will become default anyway. Both use blank and blank value has to evaluate to true for result to be set to blank value. And that's a little confusing thing that has bitten many people, including me. So therefore we have, of course, one-line conditional expressions nowadays. Result is blank value if use blank is true, else it's default. It's a bit confusing because the test comes in the middle. That's not what you used to, but it's usable. So this is what to do if you absolutely have to have a conditional expression. Okay, on to something more complex, resource handling. This is a made-up example of an imaginary database handler. Just to show an example that is as clear as possible of how you had to do resource handling once. And it's not very readable. And one of the big reasons it's not very readable is that it has a try except statement inside of a try finally except statement. So therefore we start a transaction, insert stuff, commit, and if something goes wrong, we abort the transaction, and finally we close the transaction no matter if it succeeded or not. And this is because in Python 2.5 we got the change that you could do try except finally. Before that you had to nest them like this. So this is already much better and much more readable, but even better is of course to use a context manager. That also arrived in Python 2.5. So if you see this resource handling done with try except, this is a case where you might want to change it because this is more stable, it's easier to get right. Another way to deallocate resources is to use dunder del, and this was never a good idea, partly or maybe mainly because dunder del is not guaranteed to be called. So that means that you can, for example, if the program crashes and things like this, end up not deallocating the resource. And for the reason that it was never a good idea, I thought that deallocating things in dunder del would be unusual, but I was wrong. There's tons of dunder dels in GitHub if you search for them, And I think it's Java and C++ people who start writing Python, and they just assume that you should do the same thing, because that makes sense. But you should use a context manager if you use Thunderdale. That's one thing you should change. On the topic of context managers, I would like to mention that unit tests assert races, that is always a little bit tricky to get right, is a context manager in Python 2.7 and later. So that's much nicer way of writing it, much clearer of understanding what it does. Good way of using a context manager that doesn't actually deal with resources. Also, temporary file and named temporary file are context managers in Python 2.7. Never forget to delete the temporary file again. And in Python 3.2 and later, you also have temporary directory, which we have here, which is very nice. Next patterns are about generators. I like generators. When I worked with Plone, I sometimes needed to do migrations, and the migration tool in Plone is creating a long list of nested generators, which is really fun to write, but hard to debug. But it's cool. I like generators. But you ended up writing a lot of this code, right, where you just delegate to subgenerator and just yield back the code. Well, in Python 3.3 and later, you don't have to. You can just do yield from, which is very nice. So once again, stuck on Python 2. But this is not the only thing that yield from does. It also changes how you use coroutines. But coroutines really require their own talk, and I'm not the right guy to do that. The most important thing to know is that without yield from, it's very hard to yield from a sub-coroutine in a coroutine. It apparently needs a lot of code. And I tried to then bring up the old pattern here, how you were supposed to do it before yield from, but I can't find anything. It's so hard that as soon as yield from appeared, everybody who actually used coroutines switched to yield from. So there's like no codex that exists anymore. But on the topic of generators and coroutines, I should warn for a backwards incompatible change in Python 3.7. And for that, I should explain a thing about iterators. Iterators is any object with a next method, and you signal the end of the iteration by raising stop iteration. Feels a bit weird to raising an exception to do something that's not wrong, but that's how it works. And since generators are sort of fancy iterators, you should raise stop iteration as well to stop the generator, right? Wrong. This works, and there's plenty of code out there that's done it, and I have done it myself, because if you return from a generator with a value, it says you can't return with a value, and then something in your brain, this happened not only to me, but also to one at my company, something in the brain goes, oh, you're not supposed to use return in generators, but you are supposed to use return in generators to fix this. So in Python 3.7, a generator with raising stop iteration in it will cause a runtime error, and you should use return instead. This will actually return stop iteration. So, but there's magic pixie dust going on to be able to return values, which you need to do when you do coroutines again. So this is coroutine. PEP 479, which flashed by there, that's the details if you want to know more. Yeah, so if you want to use coroutines, you really need to be on Python 3. That's the end result of that. And here is the prehistoric pattern that actually started this talk, concatenating strings by joining an empty string. This is an example from Django. I did a shorter version of this talk on DjangoCon EU in Warsaw several years ago, and they fixed most of the things during that talk. They actually changed it and committed. So I was very happy to see that they didn't fix this. This still exists. It's still in the latest version of Django. It's obviously old code. They have a variable called bytes, so it's from Python 2.5 or earlier. That's when it was written. So why aren't they just doing this? Well, you used to hear people say that concatenating strings with plus, that's slow. Don't do that. use a join. But after Python 2.5, there's now optimizations, so you can do plus now. That's what I was told in Python 2.5 and 2.6 times back in the old days. But I benchmarked it, and using plus was always faster than join, which isn't strange because you have to create a tuple or a list for this and then join it. Using join was never faster. So what does this claim come from? I think it's a misunderstanding. This sort of code is slow. You're looping over a list of strings and you're making a long list out of that list of strings in a loop. Well, this is much faster. It's around 2 times faster, except on PyPy. But I discovered something interesting here. If you're actually generating the strings that you are adding into the loop versus creating a list and then joining that list, which is what I've always been doing because join is faster when it's a long list, well, then plus is faster than join again, which is really strange to me, and I don't know why that is, but that must be some sort of magic optimization, but it was already there in Python 2.4. But this is with native strings, so it's byte strings on Python 2, Unicode on Python 3. If we switch this around, join is faster than plus again, a lot. So this is fairly unintuitive, and I think the conclusion of this is that you shouldn't do premature optimization. Always test your code. That's really the conclusion. And this pattern was suggested to me that I should bring up, and I was going to do it because it has to do with where you calculate constants in a loop, because I thought it was silly. But it isn't, because I benchmark it, and it's kind of funny. So I'm calculating this constant outside of the loop instead of doing it inside of the loop, and obviously that should be faster, right? Because I don't need to do this calculation. Well, the claim is that you don't have to bother about this anymore because CPython will find that this calculation is done that is constant, and it will actually do it outside of the loop for you. So I checked, and indeed, yes, it does. This is since Python 2.5. It's now actually finds this and optimizes it away. So is it an old pattern? Well, maybe not, because if you have a division, Python 2.7 gets slow again. Python 3.6 will still find this, and PyPy will find it. But of course, this is a stupid example, right? You could replace the code with len of the iterable and times 17.5, which is 250 times as fast. So we'll make some example that is not quite as daft. So in this case, the value that we add to result for every time is depending both on a local variable, avar, and on the loop variable, each in this case. So this is more realistic of what you would do. And now the optimization also disappears on CPython 3. PyPy still succeeds in optimizing this unless you have a power in the calculation of the constant where calculating it outside of the loop now gets to be a lot faster. 30 times on PyPy 5.4, and on PyPy 5.5 it's just 2 times again, which is really funny. So this pattern turns out to not be prehistoric after all. You should calculate constants out of the loop, just as everybody assumes that you should. And that's really my conclusion and my takeaway from this talk. You should not only not prematurely optimize your code, that's one, and two, Python is awesome because it's intuitive. The code you think should be the fastest and most reasonable to do is generally the fastest and most reasonable to do, with some few exceptions. And the intuitiveness of Python is one of the things that I really like about it and makes it really, really cool. Thank you. That's all.
Hello. Thanks, Lennart. If you have a question for Lennart, please line up behind one of these microphones here in the aisle.
Doesn't look like it.
Over on my left.
There.
Can we have the left microphone on, please?
Okay.
Yeah.
My favorite of these is for var in X range something, and then you do something with var, which almost always should be done elsewise. Is there a reason you didn't include this?
I don't really understand.
Excuse me just a moment. People, can we please not walk in at the moment? This talk is still finishing up. Thank you very much.
So if you do for X range instead of doing range, you mean?
No, I mean, almost always, if you look at the code, what they're doing with the constant is using it as an index and...
Oh, yeah, right. No, I didn't include that because that's not really an old pattern. Doing for X in range of something and then doing multiplication or using it in maths at least can usually be optimized away that you can just do this calculation in some better way than looping over a variable. And quite often when it comes to indexes as well, that you can maybe make a slice to get the things out or do sum or something else. Yeah. So that's not really an old pattern, it's just a bad pattern.
So on my right here.
Yep.
All right. So you mentioned that del isn't actually a destructor. When is del called?
Del is theoretically called when the object is deallocated. That's when it's supposed to be called. And I know that in early Python versions, I was able to make Python not call del, but in the latest versions, I haven't been able to do that. So I couldn't show code that consistently did, or at least sometimes didn't call del. But the recommendation was always, and is apparently always, that del is not guaranteed to be called, so don't do things you have to do there.
Follow up to Jack's question. This is Wesley. So in the docs, we actually suggest that people not use under del. I've also heard that under del is also called when the ref count of the object goes to 0. Is that true, basically?
Well, yeah, that should probably be more or less the same thing, yeah. If the ref count goes to 0, it should be, you call del and then deallocate the object. That's how I understand it. I haven't read that code, so can never be 100% sure, but that's the principle, yeah.
Okay. Now for my real question, which is, based on the performance measurements, do you find any kind of difference when comparing it off of a POSIX compliant system like Mac OS, Linux versus like Windows and stuff like that?
No, I didn't. I don't have a good Windows system to use. So I only tested this on Linux, yeah.
Okay, all right, thank you.
Last question.
Hey.
You showed that example of a list comprehension with print statements in it as a side effects. Would you say that's a pattern we can now use now where side effects
for
happen?
debugging, I was always almost gonna mention that, but I decided I didn't have time. Yeah, you can do that if you want to debug, but on the other hand, you can do pretty print as well. So it's not really a big thing. I can't really think of a case where I would use it in production code, because then I would use typically log instead to get the variables out to the right place. Yeah.
Cool, and that is all the time we have. Everybody please thank Lennart.
Thank you. Changing files that is consistently using hash key on dictionaries. So it's pretty common, actually. I even found this. But don't worry, the actual commit replaces hash key with in. It's just a commit message that got backwards. Easy mistake to make, especially if you're a dog. I'm impressed it knows Git. Another thing you don't need to do is to use the keys method when you list over dictionaries. I don't think this really is an old pattern. unless maybe you needed to do it in Python 1.5 or something, I don't know, but I don't think you ever needed to do it in Python 2 at least. This is not as common as hash keys, but there's a fair amount of matches on GitHub for this too. Just skip the keys call. And this code that I showed here, that, you know, this kind of stuff for corporations, you get the elevator pitch up there. If you don't understand what it says, don't worry, your boss will understand it. Tell them about us. We are apparently awesome. Everybody says so. But enough about me. This is old code patterns, because Python has gained more features over the years. And some things we used to do make no more sense. And there's lots of old code out there, so I will try to explain why it looks like it does. And old doesn't mean unmaintained. If you wrote a library or framework that needed to support Python 2.4, you had to write things in a certain way. And that code still works. So therefore, it doesn't get changed. The tests passes and everything. So you may encounter some of these in maintained code as well. There's also old tutorials and old books floating around on the internet that people still use, so they end up using and learning these old patterns. So if you're using these patterns, don't feel bad, I won't judge you. Let's start with dictionaries. When it comes to dictionaries, the first thing is stop using hash key. In has been since 2.2, it's 15 years. And if you think I'm silly for mentioning this, because I thought I would be, so to speak, let me present to you a GitHub search. So when you search for hash key on GitHub, it tends to show up every few minutes or so in commits. Not that people actually type hash key and push that, but that they are maintaining code and adding and from the latest version of Django. So you go like, ooh, but it's from a test, so it's okay. This is also fairly common, and in general, if you end up using the keys method, you're probably not doing it exactly right, because this creates a list of keys, which you sometimes need. But in Python 3, it doesn't create a list, it creates an iterator. So what you should do is this. This will always make a list. And if you want to use an iterator, you should do this, but I don't know why you would, because an iterator is for iterating over, and you can iterate over a dictionary without using iter. So, all right, enough about dictionaries. Next up, sets. Sets are useful. They have, they're very fast, and they...
Well, welcome to our second talk. Our presenter today is Lennart Regebro, and he is going to be telling us about prehistoric patterns in Python. Please make him welcome.
Thank you. Yes, my name is Lennart, unpronounceable. I've been working with Python full-time since 2001, which is a fair bit of time, and I've also written a book. This is open source. It exists on GitHub. You can fix bugs and add stuff to it if you want to. I'm born in Sweden, but I live in Poland with my wife, daughter, cats, and fruit trees. But I work for a company in Boston called Shoebox. We make a web app that helps you with a lot of the legal documentation and the legal paperwork.